First question, why climate? I think everybody in the room will have their own answer, but for me, it's about the children, and I think my generation has done a really terrible job at preparing the world for these people, these young people, and we have to do a lot better. Why cities? That's a little bit more of a complex story, and you can get to a partial answer in the new Intergovernmental Panel on Climate Change report. And they have a very interesting statement that I pulled out. Urban areas represent 67 to 72% of global emissions, okay? Essentially, majority of emissions come from cities, okay? How new cities and towns are designed, constructed, managed, and powered, essentially the whole process, will lock in, so that lock-in, meaning it's going to be really hard to change, behavior, lifestyles, and future urban greenhouse gas emissions. I mean, it pretty much tells you that cities have to be right at the center of any solution for climate change. Now, most of the action that people talk about is top-down. Carbon tax, decarbonizing the grid, electric vehicles, those kind of things. I'm more interested in the bottom-up action. Community and city-scale interventions. And why is that important? Well, first of all, 90% of population growth will take place in cities. 2.5 billion people will be added to cities between now and 2050. As we said, roughly 70% of global emissions are in cities. But also, really interesting, 90% of wealth creation is cities. So if you want to deal with jobs, with public health, with climate, et cetera, the big grand challenges of our era, I think all the action really in cities. Now, this shows some of the worst offenders on the planet in terms of greenhouse gas polluters. And the only way I look at it is tons of CO2 per person per year. Kendall Square, which we will look at, is about 17.9 tons of CO2 per person per year. Now, I think these other numbers are low, probably. We didn't do this. I trust our number. I think we're much higher average for the US than Kendall Square. Now, we need to get all that down to an average of 2.5 tons per person to have a 75% chance of keeping climate change under 2 degrees. So we look at what should be our priorities. Where can we have the greatest impact? Now, to get Kendall Square down to that area, well, that's a 7x reduction in CO2 emissions. Is that even possible? You know, so that's what we looked at. Okay, it's clear, societal imperative that we need a new model for cities, and it needs to be much more data-driven, much more simulation-based. We need to have better tools to set priorities and figure out how to take action. So we looked at Kendall Square, case study for Kendall Square. Everybody knows Kendall Square, MIT Kendall Square. We're in that area. All these amazing startup companies, and large companies. It's one of the world's greatest innovation districts, but it doesn't function well as a community. MIT owns this 14-acre piece of property, and it is an opportunity to totally transform MIT. Now, the decisions have already been made, so this is a thought experiment. But what could it have been? So we built this Cityscope model so we could look at a whole series of possible interventions. And now we're building into the back end of this kind of model. This looks really complicated, but in a sense, it's really pretty simple. We can look at the number of people living in the district, 9,800, number of people commuting in, 42,000 people commute in and out every day, wasting time and energy, et cetera. We can look at all the interventions that could improve that. We'll talk about that in a minute. We can see how each will reduce the energy consumption, the CO2 that are emitted in the area. We can then look at a fine-grained visualization of the environmental, economic, and social impact, because we want to pick those solutions that address all three. And finally, we look at clean energy sources and power to the grid. Okay, so let's go through quickly these interventions. You'll hear more about some of these a little bit later. Electric vehicles and grid renewables by 2030. This is kind of the conventional approach to dealing with climate. So we took the MIT Transportation Survey. We know where people live, their commuting mode, their schedule, and we calculate that commuting is something like 3 tons of carbon per person per year. I mean, that's already over our total, right? So what happens if it's all electric vehicles? So in this model, we can dial the electric vehicles up to 100%. So everybody now is driving electric vehicles. So how does that affect us? Well, we start with that 17.19 tons, gets us down to 15.5. This is also decarbonizing the grid in some realistic schedule. Not going to save the planet. Then we looked at hybrid work. So after the pandemic, we went from work largely centered in the office to more work as a distributed model, largely from home and third places. So we can model the impact of hybrid work. So we can, in this case, 100% of people working 3 days from home. We can also, look at a new model for office buildings, deep retrofit of buildings. We can electrify the buildings, high performance HVAC, insulation, all of that. And so we can dial these up to 100%, so we're retrofitting every building in Kendall Square. So what does that do? 15.5 down to about 14.3. We're making progress, but we have a long, long ways to go. Live-work symmetry. Now, what if we took that site in Kendall Square and other sites that are available, and we actually built enough housing so people didn't have to commute? So we end up with effectively net zero commuting. Now, that, of course, that would be housing for something like 42,000 workers. Is that practical? Maybe not. Maybe it is. But any event, in this scenario, we can dial all that up to 100%. So now we have 0 people commuting. What does that do? Now, we have housing near jobs, so we also need walkable access to all the amenities that people need. So we do a lot of work with telecom data, using replica, Safecraft information. We can look at the frequency of people of different profiles visiting different amenities in the cities. By the way, everything with an X here is not available at MIT. It's pretty staggering. Not quite true, because the MIT Museum just opened. So you could take that little X off. And then we can build a tool where we have layers of visualizations. This is walkable access to parks. She puts a park in an area that's red, it turns green. Okay, we have that covered. We can look at all the different walkabilities. And so if we have 100% walkable access to amenities and live-work symmetry, what does that do? So we start with 14.3, and now we're to 8.54. Pretty good, much better than electrifying the grid and moving to all electric vehicles. Hyper-efficient places of living. We've been working on this for many years. People thought this was kind of a crazy idea. You use architectural robotics to move walls and beds disappear in the ceiling. We started this work, gosh, almost 10 years ago. We launched a company about 6 years ago that Google and IKEA funded, and I grabbed this off TikTok. Some random person shot this little video. But you can see an office on demand, a walk-in closet on demand. He goes over to the bed, drops down from the ceiling. So we're making that work. We're now in 100 buildings in 50 cities, and I think we've convinced a lot of the commercial real estate industry that this is the future. So we can have small apartments for singles, or singles and for a couple a little bit bigger. The dashed line shows a conventional apartment, how we can get even greater functionality in a much smaller footprint at something like half the embodied energy, roughly half the cost, and the same or greater functionality. And we can go back to our Cityscope model. We can move these blocks of different types of housing around the city. You're essentially moving profiles of people and then update the simulation and see the impact. All right, so if we now deploy this more compact, hyper-efficient housing in the city at 100%, what might that do? So 8.54, and it goes down to 8.2. But you see the social impact is tremendous, because you're increasing equity and affordability for the people who are the lifeblood of the city, the young professionals and the families, et cetera. Now, since people are living close to work and they have walkable access to amenities, we don't need cars. That would be silly to, have a 4,000-pound automobile move you a half mile across the Kendall Square. But we do need mechanized modes. So we looked at something that has the best features of bike share and the best features of ride share, like Uber. et cetera. So we call it a persuasive electric vehicle. It's an autonomous vehicle that comes to you wherever you are. We've prototyped this in the city. You'll hear a little bit more about this, like a social robot, you know, hopefully is a good citizen on the sidewalk. So if we dial these lightweight mobility modes, by the way, you can also deliver package that way, packages up to 100%, what kind of impact might we have? So 8.2 down to 8.17, but again, you're increasing the social performance of the community in some significant way. Low carbon diet, local production. So if you look at a meat diet 7 days a week, you're something over 3 tons of carbon per person per year. You're over your total goal. At typical American diet, still over that 2.5. If we went to a plant-based diet, you're down to something like 1.5. If we then deployed innovation for local production, you're something less than that. So right downstairs, we prototyped our City Farm project some years ago, looking at hydroponics, in this case aeroponics, to grow food near the point of production. There's since been a whole just explosion of creative activity for robotic farming that could be near the point of consumption. And of course, you'll hear later about some, you know, technology amazing to grow meat in a lab. So anyway, the point is, if we dial that up to 100% and everybody is now eating plant-based food or synthetic meat produced near the point of consumption, what does that do? 8.17 down to 6.78, roughly the same impact that you would have by decarbonizing the grid and moving to electric vehicles. Sources of energy. Okay, so a lot of talk about solar. Solar's amazing, but it's very difficult to power a place like Kendall Square for a couple of reasons. We don't have land for these big solar farms. It's very difficult to get the right-of-ways to run these high voltage lines to connect the power production to where it's used. And locally, there are just not enough photons hitting surfaces to power a high-density city. So if we dial PV and local wind up to 100%, hardly moves the needle. Not really worth thinking about. Nuclear batteries, on the other hand, you'll hear more about that later, is an amazing technology. They can be shipped on the back of trucks and deployed in a very compact space. You can have now power near the point of consumption, which is pretty interesting. Ultimately, I think we'll have fusion. So I'm really, this is an article from Technology Review about the new Commonwealth startup to commercialize fusion. Can we build fusion-ready cities? How's that different than deploying renewables from wind and solar in terms of the microgrids and the generation, et cetera? Maybe we can put in all of the infrastructure needed and just swap out the heat source at some point, maybe by 2040 when it's available. So if we dial the nuclear energy, or more to the point, high-density baseload power in Kendall Square up, what can we get? 6.78, maybe down to 5.94. Okay, we're still not at our goal of 2.5. What is everything else? Well, it's air travel, it's durable goods, it's manufacturing, it's the internet and server farms and all of those services. A lot of the talks that you have heard to date are dealing with the first ring and the last ring. We're pretty much mainly focused on those things in the middle, which, by the way, I think are the interventions that have the greatest environmental plus social plus economic impact. It's hard to do, but I think we have to get serious about setting priorities. Okay, is this all making sense? I'm going to make it even a little more complicated. We're going to talk a bit about the city science process that we go through. And pretty much everything that you heard today starts with data analytics, insight. Like, how can we understand what current conditions are? This shows a project we did in Andorra with using telecom data to understand the human dynamics. Case of Kendall Square, what are the emissions? Then we identify all those interventions that can improve on that condition. I mean, this can be nuclear batteries, housing policy, mobility, hydroponics, et cetera. But good ideas are not enough. We need to understand what the impact is. So we move to prediction, build simulation models to try to predict what the social or the environmental or the economic impact of a particular intervention would be. I mean, assigning these numbers is an example of how we do that. But there are two more really critical steps of the process if you want to have impact in cities. You have to build consensus. You can have great ideas, you could prove that they would work, but unless you bring people together and help them create a shared vision of the future, very little happens. This is a social dynamic issue. And there's still another piece which is really critical. So even if you have great ideas and you bring the community along, what are the processes by which you can actually realize that transformation? And we're looking at new governance models, particularly how to harness market forces with creative public policy. So let me talk just for a minute about these last two. So this creates kind of the integrated city science process. But consensus, this gets overlooked a lot. Consensus, so we build, and you can see them downstairs. We'll be inviting you downstairs during lunch. What we think of as consensus machines, Cityscope. This shows the components of the Cityscope. We use projection onto optically tagged Lego bricks. We have a tangible interface. People can move them around and see the impact. We have the radar plot and other ways of understanding the impact of whatever change we're looking at. You can see the three-dimensional massing. We have an agent-based simulation. We think of this as augmented intelligence. So it's a new form of AI, using what humans do best combined with what machines do best. Or sometimes I prefer the term extended intelligence. You're actually using these tools to extend the intelligence of humans. So this is the Cityscope platform that we use to model Kendall Square. It's really interesting because these tools allow diverse groups of stakeholders to come and meet and to explore scenarios. It's the opposite of an open mic community engagement process where the loudest, angriest voices dominate. This allows people to engage in a more creative way. And I'll just briefly show one of my favorite examples. In Hamburg, working with then Mayor Olaf Scholz, we started a project there to help them design the community that would house the 2024 Olympics so that it would be a high-performance community after the event. The mayor lost the referendum. They had an influx they were expecting 80,000 refugees from the war in Syria, so the mayor came to us and said, the old project's dead, help us identify sites to build housing for the refugees. So we shifted, we built a project that used our little optically tagged Lego bricks. We held community sessions with groups of people from each district. The mayor said every district, rich and poor, has to share equally. We're not creating ghettos, and the mayor's not deciding where to put the housing. The community has to decide. So people would come and explore possibilities. They would move these Lego pieces around, and that represented housing, and they would see access to schools and shopping and mass transit, how those accesses would be altered through different locations. Then they'd come back together. This was really interesting. In effect, they were competing, each district, to see who could accommodate the most refugees. I think this process could be used for controversial topics in our cities related to zoning or affordable housing, parking, issues like that. By the way, an article in the Atlantic magazine, Germany's radical pro-refugee urban planning experiment about this project. It was really not urban planning, it was really consensus building. We've built these types of projects all over the world in many different cities, used for different purposes. I think we're just beginning to explore the possibilities. We've been doing some consulting work outside of MIT to build this Shenzhen Urban Simulation Center, a similar one in Hangzhou. We're doing some work in the Middle East. It's actually pretty exciting. This is, for me, an even more exciting application of technology than some of the new systems that can be deployed in the city. I think this is really fundamental. And then governance. I do believe that restrictive zoning policy may be the greatest barrier to climate change solutions. Remember, when I started, I talked about the IPCC report about how new cities are designed and managed and powered will lock in behavior and lifestyles. Zoning, the way it's now conceived, and it's like 100 years old, it's totally obsolete, I think is a great barrier. We're beginning to look at alternatives to that. If you have, just simple example, if you have a 3-story building in the city, you could lock that down and say, you can always build this way, but there's a new opt-in system. We will give you incentives to build more square footage, but you have to take a percentage of that and apply it to pro-social purposes, which could be thought of as in 2 categories. One are the assets, and those are things like essential housing. I don't really like the affordable housing term. You need essential housing, housing for all the people, the workforce in a community, daycare, grocery, pharmacy, things that are lacking in a place like Kendall Square. You could also create an endowment where you're staking a local token economy, rent-own programs, new business programs, even direct payments for the people that are closest to the project to realize the greatest impact. This can all be dynamic, so you get a little too much of this asset, you dial back that incentive, you dial up others. It can be algorithmic, this continuous mapping of incentives to community benefits for pro-social purposes. And then we can deploy the things that we're all thinking about: public ledger, smart contracts, data analytics, simulation. We think of this as a way to realize some new form of ESG community metrics. We will be exploring these and other issues in this room in 2 weeks at our City Science Summit. We're going to go through some of the same topics we talked about today, but we'll also be presenting a new design for the city of Kharkiv that we're developing with Norman Foster and his foundation. We'll be looking at how we can learn from this experience from Kendall Square and apply it to a new community in Kharkiv destroyed by the war with Russia. That's October 27th and 28th. Be in touch with us if you're interested. So thank you all for this session. I hope it was interesting. Thank you.